Hello everybody, welcome to Dr.K.Liu Maths channel. This is HKAL Pure Maths 2007, paper 1, and this is question 1. It is a binomial question. Okay, let's look at detail of this question. For any positive integer n, denote the coefficient of x to the power k in the expansion of 1 plus x to the power n by nck, and prove the following two identities. Okay, the first one, it is obviously by the binomial theory, 1 plus x to the power n is equal to summation k from 0 to n, and nck x to power k. Yeah, it is by the binomial theory. If we differentiate, this is star with respect to x on the both hand side. We have the right for the left hand side, we have 1 n times 1 plus x to the power n minus 1. For the right hand side, it is summation k from, because the first term is a constant term, therefore I have to write down the from the second term to do that. It is k nck times x to the power k minus 1. When you expand this one, you can see that the first term is nc1, nc1, low nc 0, because nc0, the term of nc0 is 0 here after taking differentiation. Okay, then the second term is 2 times n2x, and third term 3 times nc3 times x to the power 2, and then the last term is nck n times nck x to power n minus k. Yeah, it is the first identity we have proved. And for the second one, because you can see that it is the delimiter here for the right hand side of the identity is n plus 1. We have to integrate both hand side here. Integrate star both hand side with respect to x. It means here I write it in detail. Integrate this, I change the terms 1 plus t dt from the domain of 0 to, let me see, 0 to x. Of course, the other hand side, it means right hand side, we do the same things. Summation k from 0 to n, nck x to power k. And for the right hand side, for the left hand side, we have n plus 1 times 1 plus t to the power n plus 1, and substitute 0 and x into the terms. Okay, for the right hand side, this summation side can be factorized outside the integration side. We only need to integrate x to the power k. This is summation k from 1 to n, nck. Integrate that x to the power k plus 1 over k plus 1, and then assign, this is t dt. And then we substitute the terms 0 and t into the format. For this hand side, for the right hand side, left hand side, when substitute x, this is n plus 1, 1 over n plus 1 times 1 plus x to the power n minus 1. This is actually the terms of the left hand side of our identity. And substitute 0 into that, we have minus 1 over n plus 1. For the right hand side, summation k from 1 0 to n nck sub x into the formula, that is x to the power k plus 1 over k plus 1, and sub 0 is 0. And you can see that when we expand these terms term by term, express this is term by term, that we get the answer, we get the identity in part B. Move that terms -1 over n plus 1 to the right hand side. We have 1 over n plus 1 plus the first term of this one. The first term is this one is nc0x. Second term nc1x to the power 2 over 2. And then for the last term ncn over n plus 1 x to the power n plus 1. Yes, this is actually our we have proved the second identity of A2. Okay, B, for B. B, and it is some hints for us. Expand using 1 plus x to the power n minus 1 times 1 plus x to the power n plus 1 equal to 1 plus x to the power 2n. Expand prove the following identity. For the right hand side, I noticed that this term 2n factorial over n factorial square, it is actually 2n cn. It means this part is 2n cn, and that terms n over n plus 1, I think it is the remainder term that is. I don't know where it come from, but I think it is easy to see that for both hands that we can see it later. Okay. For this one, because there is something in the denominator here, I think for this one I apply this equation. Apply A2 into 1 plus x to the power m minus 1. Thus, we have 1 plus x to the power n minus 1 can be, let me see. Yes, it is. Oh, sorry. I think I can not apply this one. Using this one by A1, we have 1 plus x to the power n minus 1 times n. This is nc1 plus 2 nc2x plus 3 nc2x to our cube n times ncnx to the power n minus 1, and divide the n on the both hand side. This is okay. I write down like that. Okay, for that 1 plus x to the power n plus 1, and we can apply this one, and 2. This is if I over n plus 1, this can be 1 over n plus 1 times plus nc0 times x nc2 over 2 times x to the power 2 ncn over n plus 1 to the power times x to the power n plus 1, and multiply n plus 1 to both hand side. We have 1 plus x to the power n plus 1 equal to 1 plus n plus 1 nc0 x n plus 1 over 2 nc2 x to the power 2. Sorry, nc1. And then the third, this term 3. Okay, I think I write one more terms, n plus 1 over 3 times nc2 x to the power 3. And the last term, it is 1 plus n plus 1 over n plus 1 ncn x to the power n plus 1. Okay, I erase this one. Now we have two equations. One, this is 1. This is 2. You can observe that by the hints, this is 1 plus x to the power n minus 1 times 1 plus x to the power n plus 1. This is the right hand side of this one, and the left hand side is 1 plus x to the power 2n. And if we compare the coefficient of x to the power n on both hand sides, we can get the result. Therefore, for 1 plus x to the power n minus 1 times 1 plus x to the power n plus 1. And for this one, the coefficient of x to the power n, which is equal to there's no combination of 1 this constant term with this term, because the highest power here is n minus 1. Low term for this one, and for this one we have multiply this term. That is first one, n plus 1 times n0 times n over n ncn. This first term. And the second term, this one times the previous term of this one. This n plus 1 over 2 nc1. The previous term is n minus 1 over n ncn minus 1. And for this term, n plus 1 over 3 nc2. And for the previous term, it is n minus 2 over n ncn minus 2. Okay. Similarly, we have for the last term, and it is the previous term of this one. The previous term of this one is n plus 1 over n ncn minus 1 times this one, 1 over n nc1. Yeah. This is the coefficient x to the power n of the right hand side, and that for the left hand side, of x to the power n, which is 2n cn. This is 2n factorial over n fact square. Therefore, we have an equation for us. This is actually equal to this one. Okay, next step, we have to simplify those terms. You can see that n plus 1, n plus 1, n plus 1, all terms have the common factor of n plus 1. Also, all terms have the common factor of over n for the denominator. Therefore, we can factorize n plus 1 over n outside. And the first one, which is n here, and change this nc0 to ncn. This keep it, therefore square. For the second term, this have factorized outside. This factorized outside. We have n minus 1 over 2. And change nc1 into ncn minus 1. Keep this one. Therefore, we have square. And Similarly, for the third term, factorize n plus 1 and denominator of n. We have n minus 2 over 3. And change this one, nc2 into ncn minus 2. Keep this one. And finally, we go to our target already, because you can see that factorize this outside, we only have this one, and change ncn minus 1 into nc1. That is 1 over n, nc1 all square, equal to 2n factorial over n square. And move. Okay, I copy the final part. Move this term to the right hand side. That is n over n plus 1. That actually is which is our the identity, the question we want. The only difference that the order we reverse, because this term is correspond to this one is correspond to this one. Oh, sorry. Oh, crazy. I missed all the terms. Second, that this term should be correspond to the pth term of this one. This term correspond to the pth term of this one. Yeah. Okay. I hope guys can enjoy this video. If you found Dr.K.Liu Math channel is useful, please subscribe my channel. I hope I can do as much as possible, as many as possible, that of the pure maths A-level pure maths questions. Okay. If you want to support our jobs, you can join our members, YouTube member. Okay, that is very good.